right. Welcome back. Chapter 16, Part 4. Stream rejuvenation is this process where a stream gains downcutting energy. And I'm going to start, it actually is better if I show you the image first, and then we come back to these. So here you have a stream, and here's the base level. That's as far as it can go, so it's only going to carve its channel that deep, right? But maybe something happens geologically, and the land is lifted up. So remember in the video I had you watch Making North America, and how it talks about the Rocky Mountains, and that whole area has actually been lifted up because of a plate underneath it? If that happens, now the water up here has a lot more way to go down, right? It's higher than the base level. So it gets more energy, and it starts cutting V-shaped valleys. And over time, those valleys get wider and erodes. It can actually eventually wear this all back down to flat again. So it only happens because of that uplift. So let's go back to the terms. Stream rejuvenation. Geologic uplift. So in the case of the Grand Canyon, this is actually what happened. Is that area where the Grand Canyon, that whole area of the crust was thrust up. And that allowed the Colorado River to start even widening and digging even deeper. But it can also happen with lowered sea levels, which is something we haven't seen for 10,000 years. But during the last ice age, that did happen. Okay? But the higher the stream lies above the base level, the deeper it will cut. So let's go back to that picture. The higher the stream over here is over its base level, the deeper those valleys can be. Now, another thing that happens is these curves called meanders. Right? Stream meanders, we're going to talk about this a little bit later, but they usually happen on a flat surface very close to the base level, the floodplain. So they don't normally happen up here where there's a high uplift. But if something causes this whole area to lift up like the Grand Canyon, the stream is already following this curvy, twisty path. It will erode a canyon. Instead of a straight canyon, they call that an entrenched meander, and it looks kind of like this. So this right here was at one time a flat, close to sea level floodplain. But we know that forces had lifted this area of the crust up several thousand feet. And so these meanders become entrenched. They normally would only form in the end. But let's talk about stream meanders. So maybe you've been told that you are meandering through life. Right? You're just kind of wandering aimlessly. And that's actually what we're talking about. Meandering. So right here, here's a floodplain, the stream is meandering. You ever notice how rivers kind of have that curvy look? That's what happens. We'll talk about how that forms in about 5 more slides. But if something happens over time to lift this area up, right, now those meanders become what they call entrenched. And as they get deeper and deeper, somebody likes his spaghetti, sorry about that, they can actually form steam terraces, which is just evidence of former meanders. And that looks kind of like this. Here's the stream right here. At one point it was on this level, and at one point it was here. I'm not going to focus too much on antecedent and superindustrial. I want you to know what these terms are, but we're not really going to be quizzed on them, so that means probably most of you are going to skip through this, and that's totally fine. But for those of you who really want to know geography, my favorite students, unlike the ones who want to skip through, just kidding. Antecedent streams. This is where you see a stream that looks like it's cutting through a mountain as opposed to going around it, which would seem illogical, right? Water can't flow uphill, so how would it cut over a mountain? Okay? And what happens is an antecedent stream creates a water gap, and it looks like it literally just wore over a hill. And again, when you think about it, water shouldn't be able to cut through a hill, it would go around it, right? Because it has to go downhill. Superindustrial streams, don't worry about that term for now. This is what happens. Here you have this ridge, right here, the McDonald Ridge, and you look at this gap right here where this river flows through it. So it looks like the river wore through here. But think about it. How would that happen? How would the water start wearing from here, get to the top of the hill to wear down? It shouldn't happen. What happens is, long millions of years ago, this area was flat, and this ridge was not there. It was like this, very flat. And it was enough that the stream went right through it then. Maybe it was only a foot tall. but something happened to thrust that ridge up. But the ridge lifted up slow enough that every inch it went up, the water could still keep flowing. And so the water never really actually went over the hill. It just found the weakest spot and kept cutting through it. Millions of years later, it leaves this V-shaped notch, which again looks impossible, but it's because the water eroded at the same rate as the ground uplifted. This can also lead to stream piracy. And this is just literally that. Two streams that are not connected, something happens geologically to the grounds, and hills move and crusts move, and two streams that are not connected are now connected, and one stream basically takes over the other one. So here's an example. We have this ridge of mountains right here. This river flows on this side, and this river flows on that side, and they don't meet. But something happens to break this. Maybe there's an earthquake or a split, and the mountains split, and now this river has a gap. And what happens is the river used to flow this way, but now it's been captured and it flows this way. So it's been pirated, and this part dries up. All right, so we've talked about how things are built down, how streams erode, fluvial erosion, right? How things are removed. Now we're going to talk and go backwards and think about how those things that are eroded and worn down, where does all that stuff end up? Where does all the dirt in the water end up? Fluvial deposition. First thing you have to know is that water sorts things by size. So the heavier something is, the quicker it stops being moved by water. Big rocks, big trunks, big trees. The lighter it is, the longer it goes. So what happens is, as a stream slows down, when a stream gets to its end, its base level, it begins to slow down. As it slows down, it stops carrying the stuff within it, and it sorts it out so that the heaviest stuff gets dropped first. And the last thing that is left is the dissolved load. That's why the ocean is not full of dirt, but full of salt, right? The salt is dissolved where the dirt is just, suspended. Okay? Now, when a river floods, it does the same thing. If you've ever noticed after a rainstorm or a flood in a sidewalk, you kind of see how that dirt lays out that was in the water. If you've ever had a flood in your basement, you've seen this too, that when the water goes behind, it leaves kind of this fine layer of muck. And they call that alluvium. Alluvium is just the stuff that the stream has left behind, the load that was in it when it flooded. So here's what happens. Here you have a river, right? Starts up here in the mountains. And it's moving these heavy rocks. But as it begins to slow down, these rocks get left behind. And the closer it gets to the ocean and the flatter the gradient, the slower the water. And the slower it gets, the smaller the particles left. So by the time it reaches the ocean, all that's left is the chemicals that are dissolved in it, like salt and calcium, and the fine sediments like dust. And that's what gets left in the ocean. Now, those sediments can build up in a stream. A stream normally moves it. Here's a valley, right? Anything that falls down here falls into the water, so dirt, soil, rocks, and the water brings it down this way and it's moved. But what happens if the water slows down? Well, if it slows down, it can't move as much, and the sediment that's in here can actually fill it up and can fill this valley up so that when you finally get, after a couple 100,000 years, you basically don't even have a valley anymore. You have a floodplain. This is all alluvium, all flood deposits, and the river runs on top. Okay. Now, this can also be aggravated by human activity. What if we do something to increase the amount of sediment falling into the water? And we talked about this, right, with landslides. What if the trees are all cut for deforestation and all the mud flows into the river? So we can put and basically fill it up. So this can actually happen. And it does happen in areas where they do a lot of deforestation. We actually fill the rivers in, and they go from V-shaped valleys to a flat floodplain. Okay? It also happens where glaciers are. And we'll talk about glaciers in a few chapters. But glaciers release a lot of sediment in the ice. When the ice melts, that comes out with the water. But here's an example of something that happened artificially. During the California gold rush in the 1850s, the way they mined for gold was they used high-pressure water hoses, and they basically blasted the sides of river valleys and washed all the sediment down here where they would sort through it for gold. But the unintended side effect was it filled in a lot of these valleys. And this is kind of what it looks like. Here's an example from the Himalayan mountains. This used to be a deep valley, but all the sediment that was in this glacier, when it melts, comes out and it fills it up, so now it's flat. And what happens is there's so much sediment in here that the river breaks apart in these tiny little little braids. They call that a braided stream. There's so much sediment it can't stay together. It has to kind of drop it and break around. Now sometimes this also happens in the desert, because if you have a sediment-laden stream that only flows a few times a year, so think about maybe Arizona desert, New Mexico desert. They have a huge thunderstorm in the summer, and this river flows through the mountains for about a week, and all that sediment comes out here, and then it dries up. It leaves what's called an alluvial fan, right? This big, huge, basically flat deposit of all the water was in it, and the water just basically soaks into the ground and evaporates. So now we're going to talk about meanders, right, in detail. We talked about that loop, but how do they actually form? And this has a lot to do with sedimentation of a stream. So meanders are a bend, and they develop over time. You don't need to know Thalweg, but what happens is this. Let me show you this picture. Here's a river before the meander, relatively straight. But maybe there's a little bit of deposition here to make the river kind of bend. You have a slight curve. Now think about it. The water going here on the outside of the curve has to travel farther than the inside of the curve to go the same distance. It's just like if you were to spin, right? When you're spinning, like a figure skater or a roller skater, right? If you put your arms out, your arms on the outside have to go a bigger circle around than right here where you are. So what happens is this water is actually going slightly faster on the outside of the curve than the inside. And remember, faster water erodes and weathers faster. It carries more stuff. So now it starts cutting away right here. So this curve starts to cut this way. Conversely, the water on the inside of the curve travels slower. And so that starts dropping sediment out. So it starts depositing stuff here. So it's cutting this way, and it's depositing this way. And the curve over time starts to loop like this. And you get right here a meander. And that's how those form. Now here's the thing. Now this part here is a curve. So it's going to start cutting this way. And this one's going to start cutting this way. It'll actually cut this off. So what will happen is it'll actually cut this loop off. And I'm going to see if I can pause this for 1 second to get my little face out of there so I can show you that image. All right. I opened the picture this way. This one's one of the ones I want to make sure you can see, and I can't turn this off. So the meander, right, we were right here. The meander grows, this curve grows. So you get this big, huge, what's called the meander neck. And eventually this curve will cut through, like you see right here. Slice it right off. And when that happens, it's cut it off. It fills in this bank here, and now the stream has a new path. And this part right here is just left behind. And they call these oxbow lakes, right? So it's just left there. And it'll keep on doing this. And so the meanders will form and cut themselves off and start again, over and over again. And this process repeats itself. If you were to follow this with a satellite for 100 years, it would look like a rope snaking around like that. Okay, so some of the terms for that. The cut bank, this is the part of the meander where it's growing. That's the outside of the curve. And then that means that the other side, the inside of the curve, is the point bar, or the deposition bank. Okay? And the oxbow lake is just what's left behind. So let's take a look. Here is, in Australia, a river here. It's meandering right here. You see the river. So it's got those curves, right? But here is a former oxbow lake. It's actually dried up now. But you can see that the river once went like this, all the way around, like that. Oh, sorry about that. But now it's been cut off, and this is dried up. There's another one over here you can kind of see. And you can see right here that now it's probably going to start doing this. This meander is going to go this way. It might cut off this one. It might cut off this way. And they go back and forth. Here's a smaller version. You can see right here. So this is the cut bank. This is the outside of the curve. So it's actually wearing it away. And here's where it's kind of dropping the material. Another thing that happens, excuse me, are natural levees. So when a stream floods, it does this. When a stream floods over a floodplain, covers all this land with the water, and then the water eventually dries up, it leaves behind this layer of dirt or mud. That's alluvium. But in a natural levee, what happens is, over hundreds of years, this building of sediments and the idea of streams sort of interact, and it creates this natural raised barrier, a levee, high ground, right next to the river. So here's what happens. Here's the river, normally, right? But here it is in flood. So all that water is there. But when that water recedes, it leaves a thin layer of muck. And you can see over time, lots and lots and lots of layers, right? Now what happens is, so we know that in a floodplain there's all these layers of alluvium. We also know that stream sorting means that the further you are from the river, the finer the material. So the dust and the dirt and the heavier stuff's right here. So the heavier stuff is bigger, so it forms these kind of like little ridges. And you can see that over time, it forms almost like a natural ridge. Kind of hard to see at the slide. And those are natural levees. These are high points along the water that normally don't flood as easily as other points. So New Orleans was originally built on a natural levee. If you go down to New Orleans, right on the Mississippi River, the only part of the city that is not below sea level is the French Quarter, and it's built the original city on an area right here. Same thing with St. Louis and Memphis. The rest of the city is right here, which is very low and subject to flooding. So when you put it all together, you get some unique features. So here's a floodplain, kind of flat. Here's your layers of alluvium, all those years of flooding. You've got your meanders and your oxbows, right? Here you've got that natural levee, the kind of high ground right next to the river. Another thing we didn't talk about, a lot of marshes in here, are these what they call Yazoo streams. I love that name, Yazoo Stream. It's named for a city in Mississippi where they first noticed this. Because of these raised banks, it's hard sometimes for tributaries to get in there. So they flow next to the river until they find a gap and then break into it. Alright, this is the end of this part. I'm going to pause the video here, and then we will wrap up in just a little bit. So again, feel time to stretch, get up, walk around, and get a cup of hot cocoa for the next part.